Hey guys, welcome to this next unit on the Bernoulli distribution and the binomial distribution. Now, neither of these things are fully new. Last year in year 11, we looked at the binomial distribution where you're expanding a plus b to a power. So that's going to be linked in here. And the Bernoulli distribution in statistics is really just another way of looking at probability of events where there are only two outcomes. It either happens or it does not. And we've been looking at that in stats for years. We'll just be observing a few different patterns and relationships as we explore this unit. Okay, so let's get started, shall we, guys? Okay, so I've got here a Bernoulli random variable is simply a discrete random variable. Now, we did discrete random variables last year that had a certain probability notation, so we'll be reflecting on that with exactly two outcomes, basically success or failure. It happens or it does not. Okay, so we have a certain notation for this. If x is our discrete random variable, there are two outcomes. We call them 0 for failure, 1 for success. So 0 is equal to the failure, which makes sense, and 1 equals success. Now, it's important to note that these are complementary outcomes. It either happens or it does not. There is no third outcome. Okay, we've been dealing with complementary events for a while. All right, so let's have a look, see if we can identify what these look like. Okay, so here I've got which events are Bernoulli random variables. So all we have to have a look at is what is the outcome they're asking for, and is there either it happens or it doesn't happen. Okay, so let's have a look at this first one. Selecting a picture card from a standard deck of cards. Okay, so all we have to ask ourselves for this outcome, you can either get a picture card. What's the complement of that? You don't get a picture card. So this one, yes, because we get the picture card, which would be equal to the success, and the failure would be not getting a picture card. Okay, let's have a look at the next one. Rolling a number on a dice. Okay, rolling a number, any number. Okay, so we have to have a look at what the outcomes are. When we roll a dice, how many outcomes are there? There are 6, aren't they? Here are our outcomes. 1, 2, 3, 4, 5, 6. So for this one, there are more than 2 outcomes. So it is not a Bernoulli distribution. Now, if we reframe that, like this next one, still rolling a dice, so the experiment we're doing is the same, but this time we're looking at getting an even number, not any number, but an even number. Okay, so if you're rolling a dice, you either get an even number or we don't get an even number. So this one would be where our success would be getting an even number, and our failure would be the complement, which is not even, or if you want, getting an odd number. Okay. Scoring a 3-pointer in a basketball game. Okay, so think about this. When you shoot a 3-pointer, what are the outcomes? You either hit it or you miss it. Okay, so this one is. Our success in this one is getting the shot. The failure in this one is missing the shot. Okay, only 2 outcomes. You get it or you don't. All right. Now, this last one. Have a think about this. Hitting the bullseye on a dartboard. Now, have a look. There's a lot of outcomes when you throw a dart at a dartboard. But we're not saying hitting a number on the dartboard. We're saying it hits the one location, the bullseye. So when you do that, you can either hit the bullseye or you can miss the bullseye. It doesn't matter where you get on the rest of the dartboard. The fact is you're not hitting the bullseye. So in this case, yes, it will. So our success, our one outcome would be getting the bullseye. Oh, I wish I could spell sometimes. And the failure would be missing the bullseye. Now, it doesn't matter where else the dart lands, who cares if it's a 20 or a triple 10, doesn't matter, you've missed the bullseye. Okay, all right, so really all we got to think about here, are there only two outcomes? You either get that outcome as a success or you miss it, it's a failure. Okay, so let's have a look at a problem here. All right, so let's explore the one we just talked about above, rolling an even number on a dice. Okay, so we're going to have a look at how we, a few concepts here, how we express the notation, how we can look at it different ways. Okay, so I'm going to come over here and say, right, if our event is getting an even number, I can do this. Probability of getting an even number, in this case is 3/6 or 1/2. And what is the probability of not getting an even? So I'm just using the complementary notation with the little bar over the top. So in this case, not getting an even is an odd. So 3/6 for the odds, which is also a half. So remember, they are complementary events. There's nothing new so far, nothing new. Okay. All right, now we're going to start bringing in our random variable distribution that we looked at last year. So if X is getting an even number, then I can set up my probability distribution like this. Here's X, and probability of X equals the individual. So there are only two outcomes here. Either little x is 0, that's our fail, or little x equals 1, that's the success. Okay, so what is the probability that we fail? Okay, in other words, we get not an even number. That is a half. We just found that above there. So there we go, I can put that there. All right, what about the probability of success, which is the 1? Where's our success up here? Getting an even, that was our outcome. So we can put the half down there. Notice probability of 0 plus the probability of 1 equals 1 whole, because they're complementary events. Okay. Now, there's also a graphical version we can look at. So if I was sketching this up, I'm looking at this probability distribution where my horizontal axis is X, the outcome. So I only got 2. There it is, 0 and 1. And the vertical axis is the probability that I get those outcomes. So remember, probability can't be greater than 1. So in this case, there's our 1. Let's put that scale on. And probably that we fail, we don't get an even, was a half. I can draw that there. And the probability that we succeed, get a 1, is also a half. All right. Now, because these are even, there's a special name for these. If we have the probability of success being the same as the probability of failure, we call that a uniform probability distribution. Uniform probability distribution. Sorry if you can hear the rain. Okay. In other words, that occurs when the probability of x equals 0 is the same as the probability of x equals 1. Okay? All right. Let's go and have a look at an example, and then this will do us for this video, and then I'll do another one for mean and standard deviation. Okay. All right. So, I can write this, if we explore this using probability, I can write that a Bernoulli, I'm just going to do this, Bernoulli distribution is a probability distribution just like we did last year, probability distribution, where P equals the probability of success and Q is the probability of failure. Okay, and remember, Q is the complement of P. So I can write my probability distribution this way. Probability of X being X, where it can be success or failure, there are two outcomes. P for x equals 1, which means success. Or 1 minus P, which is our Q, 1 minus P for our failure. X equals 0 for our failure. Okay, so we can express our probability distribution a variety of ways. Using our data table, using a graph, or using the notation that we looked at last year when we did random variables and probability distributions. Okay? All right, let's do a quick question, and this will do us for this lesson. We'll go on to the next one. All right, so here's an example. All right, so we've got passing a test, the probability of passing test is 75%. All right, so let's explore. So first of all, is this a Bernoulli distribution? Yes, because you either pass a test or you fail the test. So if the probability that you pass is 75, the probability you fail is 1 minus 0.75 or 0.25 or 25%, whichever way you want to look at it. Okay. All right, so let's write down our probability distribution. Probability of x equals x. We have two outcomes. What is our success outcome? 0.75 or 75% for x equals 1. Remember, that is our success. And 0.25 for our failure. X equals 0. So that is failing the test. Okay. All right, guys, that will do us for this lesson. I'll see you next lesson for mean and variance.